I am a visionary. Illuminating galaxies to witness the birth of stars. And sharpening our understanding of extreme weather events. I am a helper, guiding the blind through a crowded world.
I was thinking about running to the store.
And giving voice to those who cannot speak.
Do not make me laugh.
I am a transformer, harnessing gravity to store renewable power. And paving the way towards unlimited clean energy for us all. I am a trainer, teaching robots to assist, to watch out for danger, and help save lives. I am a healer, providing a new generation of cures and new levels of patient care.
Doctor, that I am allergic to penicillin. Is it still okay to take the medications?
Definitely. These antibiotics don't contain penicillin, so it's perfectly safe for you to take them.
I am a navigator, generating virtual scenarios to let us safely explore the real world and understand every decision. I even helped write the script. Breathe life into the words en muchos idiomas y escribí la música. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
I hope you realize this is not a concert. You have arrived at a developers conference. There will be a lot of science described, algorithms, computer architecture, mathematics. Blackwell is not a chip. Blackwell is the name of a platform. People think we make GPUs, and we do, but GPUs don't look the way they used to. This is Hopper. Hopper changed the world. This is Blackwell. It's okay, Hopper. 208 billion transistors, and so you could see, I can see, there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second. So that these two sides of the Blackwell chip have no clue which side they're on. There's no memory locality issues, no cache issues. It's just one giant chip. And it goes into two types of systems. The first one is form-fit-function compatible to Hopper. And so you slide on Hopper and you push in Blackwell. That's the reason why one of the challenges of ramping is going to be so efficient. There are installations of Hoppers all over the world, and they could be the same infrastructure, same design, the power, the electricity, the thermals, the software, identical, push it right back. And so this is a Hopper version for the current HGX configuration. And this is what the second Hopper looks like this. Now, this is a prototype board. This is a fully functioning board, and I'll just be careful here. This right here is, I don't know, $10 billion. The second one's 5. It gets cheaper after that, so any customers in the audience, it's okay. The Grace CPU has a super fast chip-to-chip link. What's amazing is this computer is the first of its kind where this much computation, first of all, fits into this small of a place. Second, it's memory coherent. They feel like they're just one big happy family working on one application together. We created a processor for the generative AI era. And one of the most important parts of it is content token generation. We call it, this format is FP4. The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip. This chip is just an incredible chip. We call it the NVLink switch. It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second, and it has computation in it, as I mentioned. What is this chip for? If we were to build such a chip, we can have every single GPU talk to every other GPU at full speed at the same time. You can build a system that looks like this. Now, this system is kind of insane. This is one DGX. This is what a DGX looks like now. Just so you know, there are only a couple, 2, 3 exaflops machines on the planet as we speak. And so this is an exaflops AI system in one single rack. I want to thank some partners that are joining us in this. AWS is gearing up for Blackwell. They're going to build the first GPU with secure AI. They're building out a 222 exaflops system. We're CUDA accelerating SageMaker AI. We're CUDA accelerating Bedrock AI. Amazon Robotics is working with us using NVIDIA Omniverse and Isaac Sim. AWS Health has NVIDIA Health integrated into it. So AWS has really leaned into accelerated computing. Google is gearing up for Blackwell. GCP already has A100s, H100s, T4s, L4s, a whole fleet of NVIDIA CUDA GPUs, and they recently announced the Gemma model that runs across all of it. We're working to optimize and accelerate every aspect of GCP. We're accelerating Dataproc, which for data processing, their data processing engine, JAX, XLA, Vertex AI, and Mujoko for robotics. So we're working with Google and GCP across a whole bunch of initiatives. Oracle is gearing up for Blackwell. Oracle is a great partner of ours for NVIDIA DGX Cloud, and we're also working together to accelerate something that's really important to a lot of companies, Oracle Database.
NVIDIA builds the world's most advanced AI supercomputers. We start by creating their digital twins in Omniverse. Our latest supercomputer is a large cluster based on a liquid-cooled system with 2 racks, each containing 18 Grace CPUs and 36 NVIDIA GPUs, connected by NVLink switches. We're retrofitting an existing data center, so Kinetic Vision helps generate a 3D mesh from Navis LiDAR scanners and uses Preview 3D's point cloud processing tool to clear the existing rack.
Good morning, Ashley. Navigating to the office.
AI tools like multimodal large language models are revolutionizing the automotive industry. NVIDIA's foundation models, combined with automotive knowledge base and sensor data, create an LLM that's fine-tuned for automotive use cases. Using retrieval augmented generation, the AI assistant deployed in the car is able to perceive, reason, and assist in day-to-day driving scenarios.
Be careful. There's a toy car behind the vehicle.
AI-enhanced surround visualization gives us an unobstructed view of the environment, helping us make safer driving decisions. The assistant is also your trusted advisor, able to access the knowledge base to give you real-time assistance and recommendations in multiple languages.
¿Es posible dar vuelta a la derecha en un semáforo mientras está en rojo?
Sí, en California se puede girar a la derecha en rojo a menos que haya una señal que diga lo contrario.
Perfecto, gracias.
Its ability to read and reason through text also gives the car enhanced situational understanding.
I see you have personal belongings in the back seat. Don't forget to take that with you. We are about to go over our preset $10 limit for the fast track today. Do you want to continue?
Yes.
The AI-enhanced personalization even lets you experience your entertainment at the highest quality. The future of mobility will be defined by how cars are transformed into intelligent companions that make every journey safer and more enjoyable.
每一种颜色都能使这款车型焕发出独特的魅力。
我喜欢有质感些的灰色。
非常好的选择。
As cloud applications continue to ramp up their requests per second and high-performance computing applications increase their working set sizes, the demand for scalable solutions is more pressing than ever. Nsight Systems is NVIDIA's comprehensive performance analysis tool. Today, Nsight Systems is evolving to meet the challenges of AI applications scaling out across data centers and clouds. We're excited to introduce new features aimed at assisting application developers with microservices. Nsight Systems multi-node performance analysis is enabled by scripts called recipes that triage data to help you see and understand application performance. A recipe's output is visualized with Jupyter Notebook integration. This guides you to where optimization is needed and what the likely culprit is. Recipes help you inspect things like GPU utilization, CUDA kernel time, and now networking. Communications are a critical part of scaling out applications, so we're introducing new analysis recipes designed to help users understand how compute cold spots relate to communication. Nsight Systems can now generate multi-node heat maps to show InfiniBand congestion, InfiniBand and Ethernet throughput, NVLink throughputs, and overlapped compute and networking. We've also enhanced profiling support for popular container systems like Kubernetes and Docker. This includes comprehensive support for CSP Kubernetes services, including from Amazon, Azure, Oracle, and Google. And to meet you where you are writing code, server development is enabled by Remote GUI Streaming Container. This allows you to view reports remotely rather than needing to copy them back to your PC or laptop. And integration with Jupyter software is expanding even further. Nsight Systems now integrates with Jupyter Lab, allowing you to profile code within individual cells. You can also view textual results, such as statistics, directly in JupyterLab. Timeline reports can launch the remote GUI streaming container with a single click, seamlessly opening in a new tab. Modern-day computing is defined by GPU acceleration and AI. Scaling applications across multiple nodes and on cloud infrastructure is crucial to meeting these new demands. Insight Systems has evolved to help you build applications in the new landscape of computing, whether on-premise or in the cloud. Learn more and get started at developer.nvidia.com.
As the Earth's climate changes, AI-powered weather forecasting is allowing us to more accurately predict and track severe storms, like Super Typhoon Chanthu, which caused widespread damage in Taiwan and the surrounding region in 2021. Current AI forecast models can accurately predict the track of storms, but they are limited to 25-kilometer resolution, which can miss important details. NVIDIA's Cordif is a revolutionary new generative AI model trained on high-resolution, radar-assimilated WRF weather forecasts and Era 5 reanalysis data. Using Cordif, extreme events like Chanthu can be super-resolved from 25-kilometer to 2-kilometer resolution, with 1,000 times the speed and 3,000 times the energy efficiency of conventional weather models. By combining the speed and accuracy of NVIDIA's weather forecasting model ForecastNet and generative AI models like Cordif, we can explore hundreds or even thousands of kilometer-scale regional weather forecasts to provide a clear picture of the best, worst, and most likely impacts of a storm. This wealth of information can help minimize loss of life and property damage. Today, Cordif is optimized for Taiwan, but soon, generative supersampling will be available as part of the NVIDIA Earth 2 inference service for many regions across the globe.
High-fidelity sensor simulation is critical for developing autonomous vehicles, but it is incredibly challenging to achieve, as it requires accurate modeling of the AV's sensors and surroundings. Let's see how Fortelix enhances their workflow with sensor simulation using NVIDIA Omniverse Cloud APIs. Here's a scenario generated by Fortelix and simulated with Neuro's AI driver. This object-level representation is an effective way to test AV planning capabilities. But to train and test how a vehicle perceives the world, AV developers need sensor data. It starts with an Omniverse digital twin of the environment, along with the autonomous vehicle and its sensors. The simulation application continuously updates the digital twin. Physics and animation are applied, and sensor data is rendered. The resulting simulation is physically based, time-accurate, and scalable across cloud instances, and can be used to reproduce challenging real-world events. Omniverse Cloud APIs unlock high-fidelity sensor simulation so developers can tackle complex AI challenges on the path to full autonomy.
Hi, Sarah. I'm Rachel, your AI care manager. How are you doing after your appendectomy?
I'm good. I'm glad to be home with my dog, Dennis.
It's great to hear that you're back home with Dennis. I noticed that Dr. Chang has prescribed you some antibiotics, specifically ciprofloxacin and metronidazole, due to your ruptured appendix. Were you able to get these medications?
I was. I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medications?
Great question. The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin. So it's perfectly safe for you to take them. Can you begin taking them today?
Yeah, I certainly can. Do you have any tips for faster recovery?
Given that you have diabetes, keeping your blood sugar levels in check will be beneficial for your wound healing. Your hemoglobin A1C was at a healthy level of 5.5, but your glucometer readings from yesterday were a bit on the high side. So keep taking your metformin and try to steer clear of foods high in carbs. How does that sound to you?
I think I'll be able to avoid the carbs for the week. I need to go right now, but it was great talking to you.
I'm glad we had this talk. I'll pass along your progress to Dr. Chang.
Goodbye.
Goodbye.
Autonomous mobile robots are increasingly operating in complex, dynamic, and human-occupied environments. NVIDIA Isaac Perceptor, optimized on Jetson Orin, uses multiple cameras for 3D surround perception to detect obstacles like low-lying hazards or overhangs, which are invisible to standard 2D LiDAR. Using robust AI-based depth estimation, GPU-accelerated 3D reconstruction, and semantic segmentation, the mobile robot is able to work more safely alongside humans. With Isaac Sim, we generate massive amounts of synthetic data for training and validate the perception stack inside physically accurate simulations, narrowing the sim-to-real gap. Isaac Perceptor infrastructure will enable us to train a navigation foundation model that can perceive its environment, predict the future state, and determine the optimal action. Today, Isaac Perceptor is being adopted by industry partners and developers, bringing surround visual intelligence to mobile robots everywhere.
NVIDIA Omniverse Cloud APIs on Microsoft Azure bring data interoperability, collaboration, and physically based visualization to software tools for designing, building, and operating industrial digital twins. To build an operational digital twin, designers first design, engineer, and simulate products and manufacturing processes using Hexagon Nexus. Facility planners use Hexagon scanners to capture the real world and render in Reality Cloud Studio. Engineers work in Rockwell Automation's Emulate 3D to simulate production systems before deploying to the physical factory. Then, with Omniverse APIs, data from each of these applications flows seamlessly into a unified Omniverse digital twin in Microsoft Power BI, where teams can see their 3D data in context. When the factory comes online, IoT data is live linked to the Omniverse digital twin in Power BI. And when connected to Microsoft Copilot, factory operators can gain insights into their production data using natural language. Together, Microsoft and NVIDIA are bringing AI and collaboration to the next era of industrial digitalization.
Virtual screening for new medicines is a computationally intractable problem. Existing techniques can only scan billions of compounds and require days on thousands of standard compute nodes to identify new drug candidates. NVIDIA BioNeMo NIMs enable a new generative screening paradigm. Using NIMs for protein structure prediction with AlphaFold, molecule generation with MolMIM, and docking with DiffDock, we can now generate and screen candidate molecules in a matter of minutes. MolMIM can connect to custom applications to steer the generative process, iteratively optimizing for desired properties. These applications can be defined with BioNeMo microservices or built from scratch. Here, A physics-based simulation optimizes for a molecule's ability to bind to a target protein, while optimizing for other favorable molecular properties in parallel. MolMIM generates high-quality drug-like molecules that bind to the target and are synthesizable, translating to a higher probability of developing successful medicines faster. BioNeMo is enabling a new paradigm in drug discovery with NIMS, providing on-demand microservices that can be combined to build powerful drug discovery workflows like de novo protein design or guided molecule generation for virtual screening. BioNeMo NIMS are helping researchers and developers reinvent computational drug design.